I'm Raja Sri Ganesh. Welcome to my study room. In previous video we have learnt about concept 1. Today we are going to discuss about concept 2 and 3. At first let's discuss about concept 2. In this concept we are going to learn about reference frame. At first, what exactly is reference frame? Reference frame is nothing but it is a background from which observations are made. Right? Reference frame is nothing but it is a place from which the observations are made. And the most important point is rest and motion are relative. Right? Let's see an example for this statement. Example. For example, a person A is standing at the bus stop. Right? And two persons are moving in the bus along the bus stop. Right? With respect to person A, person C is moving. Right? With respect to person A, bus is moving. Right? So, person C will also move with respect to person A. And with respect to person B, person C is not moving. Means he is at rest. Because person B is also in the bus. With respect to person A, person C is in motion. So from this we can conclude that rest and motion depends upon the reference frame from which we are observing. Right? So from this statement we can say that rest and motion are relative. This is about concept 2. Next we will see the concept 3. In this concept we are going to discuss about different types of motion and what is distance. Right? At first let's discuss about translatory motion. What is translatory motion? The motion of a particle from one position to another position as whole is known as a translatory motion. Means the motion of a particle from one place to another place, this entire motion is known as the translatory motion. It may be any shape and any size. Next, path or trajectory. Path is also called as trajectory. Path is nothing but the line joining the successive positions of a particle in motion is known as a path. For example, the positions of particle in motions are like this. So now the path is the line joining all the points in motion is known as the path. So now the path of this particle is like this. This is the path of the particle. This is about path or trajectory and translatory motion. Next, we will see some dimensional motion. If just only one coordinate is required to specify the motion, then it is called as 1D motion. Right? If just only one coordinate is required to specify the motion, then it is called as 1D motion. Means only x coordinate or only y coordinate or only z coordinate is required to specify the motion. It is called as 1D or one dimensional motion. Right? If two coordinates means xy or yz or xz like that, two coordinates are required to specify the motion, then it is called as 2D motion. If three coordinates, all three coordinates means x and y and z, all three coordinates are required to specify the motion, then it is called as a 3D motion or three-dimensional motion. If 2 and 3 coordinates are required to specify the motion, then they are called as 2D and 3D motion. The example for a 1D motion is the bus moving on a straight road. Right? And the example for 2D motion is plane which is takeoffing from the runway. The example for 3D motion is the random motion of a housefly which is kept in a jar. And next, the important point is path is relative. For example, let's see an example for this. An aeroplane is moving like this and an object is dropped from the aeroplane. With respect to the pilot who is sitting in the aeroplane, the motion of the particle is vertically downwards, right? But with respect to the man who is standing on the land, the motion of a particle is parabola. From this we can conclude that path also depends upon the reference frame on which we are observing, right? From this statement we can say that path is relative. Next we will see what is distance. Distance is denoted with capital S. Distance. What is distance? The length of path is known as the distance. We know what is path, right? So next, its SI unit is meter. A meter is denoted with small l, right? And its dimensional formula is m0 L by t0, right? It can also be written as L1, right? Next, it is a scalar quantity. A scalar quantity is nothing but it has only magnitude. It does not depend on the direction of the physical quantity. And another quantity is vector quantity. The vector quantity has both magnitude and direction, and the vector quantity does depend on the direction of the physical quantity, right? And next, shape and length of path is relative, right? We know that shape and length of path is relative, so that the distance is also relative. This is about concept 3. In next video, we will discuss about concept 4, which is about displacement.
Thanks for watching. Please like, share and subscribe. See you in next video. Bye bye.